Lino is North American VP of Sales for MultiTech, has 25 years of experience helping companies deploy successful IoT solutions leveraging wireless communication technologies. At MultiTech, he leads a team focused on revenue growth and expansion into new industrial enterprise segment through strategic partnerships with distributors, value add, system integrators. Prior to joining MultiTech, Lino held different positions in sales, business development, and system and product design with Motorola, Ericsson, Wavecom, and Sierra Wireless. That's a lot.
Yeah, I'm old.
Lino earned his bachelor's, a Bachelor of Science in Electrical Engineering from Texas A&M and a Master's in Engineering from University of Florida, making him an aggregator.
There we go.
Please welcome us in joining Lino and obviously interact, ask questions along the way. Thank you.
Thank you. Appreciate that. Good afternoon, everyone. I was here last year, and last year my topic was LoRa 1, which is a wireless technology for sensors. This year I figure I'll kind of go to the other side, which is go low throughput, low speed to broadband experience. So before I get started, I just want to kind of check the room to see how many of you have heard of CBRS or private LTE networks. Just by show of hands. Okay, not many. All right, so CBRS stands for Citizen Broadband Radio Service. And the goal here is just to give you a feel for what that is and what that enables for companies. Typically, you wouldn't think, though, if you're in the enterprise, when you're building a private network, you're not necessarily thinking about building a cellular network, right? Because you have choices with Verizon and AT&T. Your focus typically it's around an Ethernet, a wired Ethernet network, or a Wi-Fi network, for example. But with the availability of this spectrum, now companies have another choice. And some of the benefits of the cellular technology translate nicely into some use cases. So again, I'll give you a little bit of the history behind CBRS, how it came to be, how the FCC made it available. Then talk a little bit about what it takes to put something together. It's not just go to Radio Shack and get the parts and then bring them into your shop. And then I'll provide some example use cases of some of the early drivers for adopting the technology. Okay. So before I do that, I just got to cover a little bit about my company, MultiTech. Some of you may already be familiar. So we're a privately held company. We were established in 1970, so we've been doing connectivity solutions for over 50 years. So we go back to analog days. And in the early 2000s, we shifted focus to wireless technology. So that is our core competence, is Bluetooth, cellular, LoRa, and others. We do have manufacturing in the US, so a lot of our cellular products, LoRa products are manufactured in our headquarters in the Twin Cities in Minnesota. We do other kinds of products that are more customized for some pretty large companies. So those tend to be high volume custom products. We offshore those just from a cost saving perspective, but a lot of the stuff of our core business is still done here in good old USA, and we're proud of that actually. We make equipment for the medical field too, so we have all the right certifications to be able to support that. If you want to come and visit, welcome to, but don't come in the winter. Yeah, I've done all my travel for the year already. All right, so just to kind of explain where our product offering fits, and this is important, right? Our focus is the wireless Internet of Things. And so what that means is companies that have assets and equipment that they want to connect. Why would they want to connect a piece of equipment, right? It's just equipment. It's just a machine or what have you. And there's few drivers for that. One could be compliance. So an easy example, food and beverage restaurants, they are required to maintain certain temperatures and do certain things around food safety and food compliance. So they have to, they can either have somebody with a clipboard going around every hour taking temperature measurements, or they can automate that process. So that's one. The other one is companies that have stranded assets that have significant value. By connecting that asset, you have a way to not just monitor the health of the asset, but at the end of the day, it's preservation of that, right? Sometimes the cost of that asset failing can more than pay for an investment in connecting that asset. And the other one is processes. Take a manufacturing site. If you can automate the process of monitoring different things and collecting data Over time, that data can be analyzed and reviewed, and then you can maybe improve the way you do things, make the process more efficient, reduce periods or whatever. So those are some examples of that. So what we provide is the end devices that allow that connectivity. And the reason you're connecting is you're trying to pull data out of that asset, and that data. And so we help the customers from that endpoint. It could be a sensor. We can provide a sensor. We can provide edge connectivity. Customer already has the controller, already knows what they need. They just lack the connectivity. We can provide a modem that can be embedded in there to pull that data out. Especially legacy devices, if they're not necessarily that smart, this is, if you look at some of the SCADA systems in some segments, they're still using serial, for example, right? And there's not a lot of intelligence there to retrofit and put something in the device to be able to collect the data. So you can use a more intelligent device. So think of it as an edge router that you can just plug in. The edge router has all the intelligence. So, in essence, it looks like either a serial cable or an Ethernet cable to that asset. But then now you have the ability to do that. And now it's becoming more popular as you're connecting more and more devices to do some of the processing on the application, making some decisions at the edge too. So our devices also have the ability to run and host applications on the edge. So for example, if you're reading temperature, you have two ways to do it. You can read temperature every minute, and if the temperature is the same, you send it every minute. But if it's not changing, you're wasting backhaul, basically. If you have a small, simple script, for example, you can read the same temperature and only report on change or extend your reporting interval. And that's important, especially when you're using, for example, cellular, where you're paying by the time that you're on air sending data. So that way you can optimize that. So those are some examples. In some cases, you can also add some decisions. So if it's a critical event, you detect there's a critical hazardous event, you can have the application cut off power or do something and then report to your head-end server for analysis and post-mortem type of deal. So edge intelligence, and then we provide software tools around our devices to help facilitate that. Where we stop is where the data gets delivered to your system. So from that point on, that we fall back. More often than not, customers already have either partners or their own systems to be able to do that. So our focus, again, is collecting data from the edge, delivering it to your systems for analysis and whatever you need to do there. So, and our focus on the wireless side is LoRa. That's a long-range wireless technology in the unlicensed band that is great for sensors, is very secure. OnGo is actually the acronym for private cellular. So we do private cellular and public cellular devices, 4G, 5G, and then we actually do a lot of stuff on Bluetooth that is not necessarily obvious to a lot of people, but there's a lot of faucets, hand sanitizer dispensers that have Bluetooth connectivity for monitoring, does it need a refill or not. So we do a lot of the electronics behind many of those consumer-like products. As well, and with that, we have quite a big know-how out of our Toronto facility around Bluetooth. And some of these technologies, as you can see, they're kind of complementary. So they're not like one or the other. LoRa can work with cellular, Bluetooth can work with cellular, and so on. You can have private and public LTE systems as well, leveraging what's available. All right, so before we get into CBRS, let's just talk about enterprise wireless connectivity in general, right? So typical case is Wi-Fi. Who doesn't have Wi-Fi in their offices now, right? It's pretty much there. Who builds that out is usually the IT department, right? They're the ones that have to go in, design, and upgrade and maintain and make sure that everything is deployed correctly, that you have the right coverage, and more importantly, too, that security, which is a big, an important consideration, that they've taken all the necessary things for that. They also, if you think about private networks in general, too, they're the wired network, right? The Ethernet around any facility, that's a private network as well. What's the challenge of a wire versus wireless, right? Wire, you got to plan, because you cannot just say, okay, I need to put an Ethernet port over there. Okay, well, how, right? So it takes a little bit of effort, planning, and can be costly in some cases. Wireless makes that easy. I put a Wi-Fi access point on the hallway, and I light up this room, and everybody has internet connections for the business application. So the question becomes why would a company want to invest and build their own private cellular network? Why not just use Verizon or AT&T? One is cost. So it's a balance of operational cost of having to. If you're a big company with many cellular lines, that can add up to a lot of value. But the other one is you don't have the same level of control, right? Because you have your devices, you're going on a public network, you're relying on that service provider for all the aspects related to your corporate security. So there's some things that you may feel comfortable doing, and there will be others that you'll not. So, but let's look at what are the benefits of considering building a private cellular network for your company inside your, either office campus or university campus, or if you're in oil and gas, for example, in your area where you have your operations. Number one is the flex. First is based on an open standard. So interoperability is pretty good. You're not stuck to one vendor or locked into any proprietary stuff. It's the same protocol, the same specifications that public networks run on. Two is you have the ability to do with broadband 4G, and there's also a path to 5G. So there's three key pieces of, especially around 5G. One is it's a technology that has ultra reliable low latency, much better than Wi-Fi and other enterprise wireless technologies that are available. So now if you go to manufacturing plants, there's a lot of automation. There's a lot of robots running in the manufacturing plant. You have autonomous vehicles too. And I'll have a couple of examples that show that. So the latency side of it, it's important. It's not just that it's, just a few milliseconds of latency, but the reliability that is consistent, right? So I don't know if you ever do ping tests on a AT&T or on Verizon, but at times you go in there and you see a latency of 20, 30 milliseconds. You try a little bit later, it could be 300 milliseconds. So if you have a critical application, that big difference can have an impact on your solution. So, and you can control it because, one time that ping can go this way through a data center in Charlotte, bounces over here, and then it hits whatever it needs to hit. The next time it goes through a data center in Tennessee and somewhere else. So you don't control that piece. By building your private network, you have full control of that because, it's all on-prem and you control all the routes. So that's part of it. The other one is cellular is great for mobility. Wi-Fi, not so much, right? So it's great for broadband if I'm in a fixed position, but how many of you walked around a big facility and all of a sudden you got good connection and all of a sudden it's like, I got no signal, right? And if you're in a mobile application, like if you have a connection and you're moving around, if there's not a smooth handoff from one access point to the next access point, that connection drops, so you lose that opportunity. Cellular was built for mobility from the get-go, right? It was designed for having a phone with you, and wherever you are, we'll hold that connection. So it's great for that. So it can support not just fixed point applications for a broadband connection, but it can also support mobile applications, including you as the user. You can actually replace your cell phone and use CBRS for your phone calls and other services. And last is it's also scalable. So people might need, if you're doing a video application, you need a lot of broadband, but if you're connecting a temperature sensor, you don't. So there the concern is more about the ability to connect millions of devices, so that massive machine-type communication is also supported with private LTE or 5G. It's the same standard. It was designed and ready for that. And it's also complementary. I put LoRa there because that's one of those low throughput things you can integrate that with your private LTE network. So once you have the infrastructure, you can piggyback on that as your backhaul for other systems and other solutions. Any questions about this piece? So this is just more making the case like, yes, it provides you that, it gives you a path to 5G, so it's not, the same over a period of time, and it's standards-based. So as new things come into play, the ability to have your own network, you'll have that capability also to evolve with it as well. So highlighting some of the benefits, number one, remove the wire. You can get as good or better as a wired internet connection. In 5G, you're talking about speeds of 1 gigabit per second, which typically in Ethernet, 100, maybe 1,000 bits per second. So just pretty much the equivalent. But the nice thing about removing the wires, and we have one of our customers, they're big paper mill company, one of the big names in there. And the reason why they're adopting is, the factory is never static, right? There's always the need to expand into new lines or relocate lines and stuff. And big part of that is not just moving the machines, it's actually moving all the network with it. And if it's a brand new area, bringing wiring and stuff is quite expensive. With this, it's just move everything. The device goes with it. As long as you're within the coverage, you're still connected. So it makes a pretty compelling case for that. So in fact, I think manufacturing is one area where we'll see a lot of private LTE adoption as a way to get rid of the wired network and replace it with a wireless network that can meet all their requirements for capacity and latency and others. Improved performance, again, the fact that you control the network from the radio access all the way to the core to your, to the rest of your systems. You can control the speed, you can control the security. I mean, you can fully contain it and don't have that network go outside at all, so you can protect it as well. So the enhanced security is important. And then, the path is not static. You bought it and you're stuck with it, and 10 years from now it's obsolete. There is a path within the private LTE using CBRS spectrum to migrate to 5G, and then eventually, when the next G comes in, which 6G, 7G, there'll still be a path because you have enough spectrum to do what public carriers do as well. So what is the one thing you need to build your own private network? You need spectrum, right? So in Wi-Fi, relatively easy. It's unlicensed. You can either do 2.4, you can do 5 gigahertz. It's available. You put it in there. Yeah, you might have some interference. That's the, the trade-offs that come in there. The other way is you can buy the spectrum. So one way is you got tons of money, you don't know what to do with it. Next time there's an FCC auction, you spend a couple $1 billion and you buy yourself a chunk of spectrum, right? Where for Verizon and AT&T, absolutely makes sense. That's their core business. That's why, that's their precious commodity, right? It's they own the spectrum, and that's what gives them leverage. So not likely an option for the enterprise. And then plus, the spectrum that may be available for you to buy at a reasonable price may not be a spectrum that is available from a technology standpoint because, it's not part of the 3GPP standard. So you got a frequency that nobody builds anything for. So not a good option. The other one is you can go unlicensed. So I call that the Wild Wild West, right? There's a lot of that on that 900 megahertz spectrum. A lot of unlicensed mesh-type radios. If you're out in West Texas in an oil field, chances are you're probably somewhat isolated. There's probably not too many others you're competing with. But if you're in a metro area, if somebody's interference with your network, you don't have too many recourses. You cannot call the FCC and say, hey, somebody's interfering. Say, well, it's unlicensed. Everybody has the right to use that spectrum. So CBRS opened a third option, which they call share spectrum. And I'll go into what that means. So it's still kind of unlicensed, licensed. So it's sort of a hybrid mix in there. What's nice is it makes the spectrum availability barrier a lot lower for enterprise. And there is, the FCC still gets involved in making sure that everybody plays nice, right? So you're still sharing the spectrum. There may be places or times where you might run into an issue, but there's a mechanism that can help sort of make sure dynamically that frequency usage in a particular area is coordinated in such a way that you can actually enjoy the benefits of it. So let's get into that. So now let's dive into CBRS. So again, stands for Citizen Broadband Radio System. It is shared spectrum. So what happened is, and by the way, fallow. I had to look up that word. I didn't know what he meant, but everybody knows what that means? Fallow spectrum? Yes, ma'am. She does. Okay, so basically what they realized is there were 150 megahertz of spectrum in that mid-band range, the 3.55 gigahertz to 3.7 gigahertz, that was pretty much underutilized, and that's what fallow means. It's a resource that is being wasted, really. Having said that, one of the incumbents, one of the users was the US Navy. So all the aircraft carrier fleets use that spectrum for radar operations. And so you can't touch them. Now, what are the chances you're going to see that here in Raleigh? Not likely, right? If you're in a coastal town, maybe, if they're running a drill in that particular location. But I think I don't know how many of these carrier groups that Navy has, but it's probably less than 20 or 30 maybe. And chances are most of them are everywhere and just a few around this area. So basically not used a lot. You have to give them priority, but they don't use it all the time. There were some fixed satellite stations, but very underutilized. And then there was some wireless service providers, more rural type, that they were really not using it either. So they were grandfathered in until 2020. So pretty much, they're no longer, they were the incumbents, but they're no longer an issue there. So bottom line is now you have 150 megahertz of spectrum, and the FCC decided to break that into 10 megahertz chunks, which is perfect for cellular. Roughly the channels are 5, 10, and 20. So 10 is pretty good bandwidth for running and providing broadband services. And then they decided to create a tier approach. So first tier, and they are the top, and they have the primary actually are the incumbents. So again, primary will be the US Navy. Then the next, they decided to take 70 megahertz, and they auctioned those off in blocks at the end of 2020. And the way they decided to do that is they did it at a county level. So every county in the US, and I have a slide there, but it's 3,000 and change, had 7 channel blocks available. One company could buy up to 4, no more than 4. It was capped at 4, but it was available for purchase. And you'll see the results of the auction in a slide coming up. So just to see the level of interest that it generated. Then they said, you know what, we're going to take the other 80 and we're going to make that into what is called general authorized access. So that's kind of an unlicensed space. So they said, if you don't want to go ahead and spend money buying, it's called a PAL, a priority access license, a PAL block, you can still use it just using the GAA. There'll be, you'll have lower priority than some of the others, but it's available for you to build your network. And if you decided to buy a PAL license, you can actually mix, and you can use your PAL license where you would get certain level of protection, but you can still make use of our GAA spectrum as well. So that's kind of in a nutshell. So quite a bit of spectrum, not very utilized, but it was broken into that. So you really have 3 tiers in CBRS. You have the incumbents, top priority. The next priority will be the PAL licensees, priority access. And then the third tier will be that GAA user base. Just to give you an idea, and this is where the underutilization came into play. So on the left side, you see the federal protected zones. US Navy, no surprise, right? It's mostly along the coast, US coastlines, right? So that's where, if you happen to have the US Navy carrier group drilling in your area, they'll have priority over everybody else. And then look in between. You see, there's hardly anything. So it was pretty much not being used and available for some other applications. The one on the right shows some of the wireless service providers that, some of them had to give up their licenses. And then some of that was also fixed satellite. But bottom line is a lot of ground in the US that was pretty much open for using that spectrum. So that was the rationale behind the FCC doing that. So 2015, they said, hey, we got this spectrum, we got to figure out what to do. They were, just like FCC does, they take input from everybody in the US. And there was an industry group called the CBRS Alliance. It's also now changed to the OnGo Alliance, but it's CBRS or OnGo Alliance. They got together and they made the case. This is perfect for cellular. So they put all the requirements, specs, and they kind of came together as a group together with the FCC to make this spectrum available for private LTE or private cellular deployments. So I mentioned the auction. So again, there's 3,233 counties in the US. Trivia question, how many counties in North Carolina? Very good. I like nice round numbers. So yes, 100 in North Carolina. So North Carolina had available 7 licenses per county, so 700 blocks, right, were available in the state of North Carolina. And there were purchases. So the way that it works is that if you got awarded the license, so if you won the bid, you get a 10-year auto renewal that. And the commitment is you have to at least build up 50%. Use it 50% in that 10-year period to be automatically renewed. So give you a lot of time, and you can actually sub-license. So if I purchase the license, and I'll give you an example. Utilities were interested in this because they don't like OpEx. So this is a way for them to build out their own private infrastructure and avoid that monthly recurring. Alabama Power purchased the license, but they have a sister company called Southern Link, which is a private cellular operator. They sub-licensed the CBRS spectrum to them to build that out. And so that was the use case. So they're using it for their own utility operations, but the other thing Southern Link is doing with the state of Alabama is because this is broadband spectrum, they're trying to close that digital divide. So they're trying to set up a service where they can offer broadband service in rural, underserved areas as well. Again, I mentioned that each company could only buy up to 4. So that was a cap on that. But as far as the success, out of the 3,233 counties, only 13 did not buy any of the priority access license. I didn't even bother looking them up. I'm sure they probably don't have a need whatsoever. And there were 2,500, so a big chunk of those bought all licenses. So everything that was available, they purchased. Of course, some of the big buyers were Verizon, Dish Network, not surprisingly, but there was also universities purchased licenses and others purchased licenses, utilities and others purchased licenses as well. In areas where a POD license was not sold, that spectrum can be used by the GAA user. So it basically, nobody purchases it, it goes in the pool, you can use those 10 megahertz channel block that wasn't awarded to someone else. Questions to this point? Yes?
Can you find out, is there a database or something to find out?
I'll get to that in a minute. Yes?
So are there dual band handsets so you can pass off from CBRS to regular subscription?
Good question. And we got to thank Apple for that. When Apple introduced the iPhone 11, they make sure CBRS band 48 was included in it. So that, at the end, that gives you the ability. You have to set it up in the service, the way you set up your service. But yes, if you're asking is the ability to roam between, private network and a public network, you can. And in fact, that is a desirable feature because if you're on campus where your company made the investment, you want to use your network. You don't want to use the public network where you're paying for a service. But if you leave the facility and you're outside the range, you want to still be connected. So that ability exists today in phones, and it exists also in user equipment for other purposes, so routers and others, like a mobile router, for example. If you're in a mining facility, for example, which is one of the segments that is deploying private networks, all inside the location, you're using your own private infrastructure, but as soon as you leave the facility, you can switch over to the public network. So that capability is pretty good. Yes?
I refer to this as a broadband system.
Yes.
Many industrial applications, you're just going to have small packets
Yeah.
being sent back and forth from time to time.
Mm-hmm.
How many of these really utilize the entire 10 megahertz and fully utilize the bandwidth?
Yeah, it's use case driven. So clearly the decision to make the investment you have to have, okay, I have this problem. Here's some ways that I can solve my problem. I tell you on the distribution and logistics center where I've seen adoption is they're going a lot to autonomous vehicles. So you have, for instance, autonomous forklifts. And for that, you need the latency, you need the speed, but more importantly, you need a reliable handoff as you're moving from one end of the facility to the other. So that's not necessarily bandwidth driven until they have as a failover, right? Because machines can fail, and last thing you want is a forklift going nuts in a Amazon warehouse, for example. Is they also use a lot of video cameras, and they have the ability to do remote drivers. So they have people actually sitting in another location, and they can actually take control and drive the forklift remotely. And for that, you need video and stuff. So that's where you would need a driver for that. So the bandwidth requirement is that, but more importantly is, if you have multiple use cases, then it justifies making the investment. The other piece too is with the ecosystem of vendors that are playing into this space, the cost of building a private LTE network is not that far off of the cost to build a private Wi-Fi network. Like an enterprise Wi-Fi network, the investment dollars are similar nowadays. It wasn't the case in the beginning, but now it's the case. Okay? All right, so how do you go about building that, right? So you need user equipment, and that can be from tablets to phones. I mentioned Apple is one example. They introduced that in the iPhone 11. Samsung now has devices also that support that, and of course, tablets and other devices support that. So that would be more for your staff. Routers for connectivity inside the facility. Bridges or USB modems to connect laptops. All those products are now available. So you need the user equipment. There's plenty of choices there now. Then you need to build a radio access network. In cellular, they call that the E-Node Bs. And there's two types of radios that you can deploy. A Cat A radio is meant more for indoor. You can put it outdoor, but if you put it outdoor, you cannot go higher than 6 meters, or about 20 feet. And the power on the Cat A device is restricted to 1 watt. So for a small-scale deployment where you don't need to cover a big campus, that's a good option. Cost is also lower. As an example, in our factory in Minnesota, we have 3 of those inside our factory, and we use it internally, but since we make end-user equipment, we also use it for testing as well, right? So we have three of those Cat A radios. Now, if you're in an oil field and you want to have a broader coverage, you can go to a Cat B device. So that's a 50-watt device. You can mount that on a 300-foot tower. So that's closer to what you would see Verizon or AT&T do, the type of installations they do. The caveat for that, though, is that you have to have a professional certified installer do that installation. So you can't do it yourself unless you get your people certified for that. And there's a process to be CPI, they call it Certified Professional Installer for CBRS. So that's the caveat on the Cat B devices. So it all depends on your deployment. That's where you typically would work with a company that there's plenty of companies now providing private LTE deployment and planning services. Of course, the vendors that sell the infrastructure can also assist with that. And you can have a mix too. You can have outdoor and indoor combined. So it's just not unlike what you would do when you're designing a wireless network, right? You do your surveys, you do your estimations, you see where you're going to have most utilization, and then you go about it and make your choices. Cost of the infrastructure has something to do with it. So that's the radio access side. Then you need a core. In 4G, it's called a volt packet core. So the data from the radio has to go somewhere, and typically it's, you want to connect to the internet. So the volt packet core for 4G has all the components in it. So, it has your serving gateway, your packet data network gateway. It has your home server where you hold all the database of the users, and the mobility manager in the case that you need to authenticate the users, but also make sure you're tracking them as they're roaming or moving or handing off from one side to the other side. So that is available there. There is a path to a 5G core. So the nice thing about if you started in 2020, 2021, and you deployed an LTE network and now you want to migrate to 5G, the nice thing with 5G is that you can just change the radio access side and put a 5G radio there. And with 4G, the evolved packet core can handle the 5G radio. You're not optimizing or taking advantage of all the 5G benefits at that point. 5G would work the best when you have your own 5G. It's called standalone core or the 5G core. And what they do there is they just split the user and control functions. So the architect a little bit different. And that's when you would get your ultra lowest latency and some of these other things that I mentioned. But you don't have to take that step right away. So if you already have a 4G network built in, you can just add 5G radios, leverage your packet core, and go for that. So a couple questions on what is involved here. Well, since you're talking about small-scale deployments, you don't need to deploy a packet core like you would see on a Verizon or an AT&T. In fact, so much so that for like in our case, this packet core can sit on a data center, can sit on the cloud. There's companies that actually offer that as a service. So all you need to do is invest in that and then subscribe with them here. Or there's now manufacturers of this CBSD, the Citizen Band Radio Service Device, where they're actually putting the packet core inside the thing, because it's just software at the end of the day. So if you just have one or two that you want to deploy, you run the packet core right on the device. So not complicated, not as expensive to deploy with all those choices. So that part is pretty much, that's what, on a high level, that's what a cellular network looks like. So you have a radio access network, they call E-Node Bs instead of CBSDs. You got the packet core, and then you have a packet data network gateway to connect outside to the outside world or bring incoming traffic into the network. What's different with CBRS, and these are the pieces, somebody asked me about how does the FCC have a database, or how do they know who's doing what? And the answer is yes. And that's the share part, that's the dynamic frequency coordination that needs to occur. So the other elements you need are these entities. So every time you deployed a CBSD, you have to register that with the FCC. So the FCC holds a database of every company who's deploying a node. They know the location. They know whether you're a PAL user or a GAA user for every site. So every time you deploy one, you can just randomly pull one out of the box, light it up, and say, okay, you got to register that with the FCC. You also need to subscribe to what is called a Spectrum Access Service. So there's a group of companies that the FCC awarded the business to do this, is that they're actively monitoring spectrum utilization. So they're the ones that are brokering, like if you light this up and you're using a GAA license, they're aware of other users in your area. They're aware of who are the priority access license users. So they're able to make sure that they're coordinating. So what that means is for this service that you have to enable, you don't have a choice. You can't deploy it without an access to a SaaS provider. You have to provide a connection. So all your radios have to be connected to that SaaS provider. So they have the ability to monitor, and if they need to move you from this channel to this channel, they have the ability to do that on the fly. They'll try to do that to move you instead of turning you off, just so that they don't disrupt your operation. But if you're a GAA user, that's where you're at the lowest threshold. If there's no place to put you, they'll shut you down until the interference or whatever of the circumstances change. But that is a requirement, and that's usually a paid service. So you have to pay the SaaS provider to provide that for you. The other thing the SaaS does, and that's related to the top tier incumbent, and primarily the US Navy, is they also have an environmental sensing network called ESC. So what they do is, and this is literally one of them, they have sensors along the coastlines where the Navy operates, and they're monitoring for, number one, the Navy, and then what's around it. So they're making sure. So if there's operations ongoing along that coastline that can cause interference to the radar on the aircraft carrier and the ships around it, they also take that information, and then they use that data to dynamically move you if they need to. So that's an important piece of it. So that is pretty much what you would need to implement your own private LTE network. Now, on the SaaS side, if you're wondering how costly is it, we had three radios in our factory. Grab onto your wallets. We paid $12 a month for the 3 radios. So it's relatively inexpensive, right? So it's not like a showstopper whatsoever. It's designed so that you get wide adoption of it without putting a lot of overhead. Some companies may have reservations about having to provide that external connection to a third party, but that's a choice you have to make. In some cases, if that's a showstopper, then that's a showstopper. That would be more of a business decision. But all it is an internet connection out to them, so they can have control of that. I mentioned here on the packet core again, AWS is in it, so you can go to them and they can serve that. Cellular is another company. There's multiple choices for using a cloud-based packet core if you don't want to make the investments. It all depends on scale of deployment. Usually you would go to cloud if you're planning to do multiple sites over a wide area, but if you're just doing 1 or 2 sites, you can either run it on-prem or run it on the radio. All right, questions about the architecture in high level? Yes?
Yeah, the system is going to require more than one tower operating simultaneously.
Mm-hmm.
With separate frequencies of the 2 towers, or is there some sort of spread spectrum you see or any type of?
No, it's not spread spectrum. It's 3G, PP, LTE standard. But what you do there is, and that's why you have multiple channel options, so you can play with, and just like cellular works, right? You use these frequencies here. The adjacent cell site has to use different frequency set, but if you move over here, you can start reusing frequencies. So that's part of your planning. But usually you would have that. The other option you have, if you have a PAL license, you can take the 10 and split it into 2 5-channel banks. for example. And those are some of the choices you have. You give up a little bit of the speeds, but that's another choice. But that's where you would have, in some of the counties, that's where you had some users would purchase 2 or 3 or 4 licenses, so you have 4 channel options. And with that, I think you have a pretty good way to do your frequency planning. Any other questions?
So primarily were they municipal lines?
No, it was all over the place. So, Dish Network and Verizon bought a bunch. In fact, I think the next slide covers that. I'll skip this one, but, oops. Let me see. Must have hidden it. Give me a second. I manually show it because, I skipped the slide, so sorry for that. So that's kind of how it's distributed. Actually, I did show it. I did show it. Don't have my glasses, so I'm trying to find the icon here. There we go. Works. So sorry, ask the question again?
Just I was wondering if it were mainly
Yes.
municipal.
Yes, that's the slides, So that's where I was going with it. Just went backwards in my head. So these were some of the drivers. So I'll give you examples. Universities purchase licenses, utilities purchase licenses, some mining companies purchase licenses. A lot of wireless ISPs, rural ISPs purchase licenses. The big carriers purchase licenses. And that's the PAL side of it, right? And GAA, is spread out some more. So this is kind of a distribution, and this is probably about a year old, so it's probably changed a little bit. But certainly manufacturing, utilities, energy, oil and gas. I think Chevron purchased licenses and in Texas, just because they have areas where there's nothing, so they pretty much are kings of what I call wireless private infrastructure. They have microwave, they have fiber, they have all kinds of technology to provide communications to where they operate. So with this now they have that option. Government was big, and what helped CBRS adoption was the actual first systems they were green lighted to start deploying network was around early 2021, right after the PAL auction. And if we're right in the middle of a pandemic, so a lot of municipalities deployed the network so they can provide broadband connectivity to students, children, right? They were remote learning for 2 years nearly. So, and some of them did not have a broadband connection, so this was a way to provide that relatively quickly. So that's that. And then, once the city has that, they can provide citizen broadband services. They can use it into their, monitor street lights or provide connectivity for their workers and so on. Hospitality is pretty big. If you go to Vegas, Caesar Properties, they actually have a private CBRS network that they're in the process of rolling out with JMA Wireless, I think. So all the hotels in that strip will be using CBRS instead of Wi-Fi, right? It makes sense because you get the mobility side of it too. So you can go from one property to the other and enjoy the benefits of the connection. So how fast is the adoption going? So since April 2021, when the first deployments were occurring, to January, so beginning of this year, 121% growth. The OnGo Alliance, or the CBRS Alliance, that is the industry group that is trying to piece everything together, making sure everybody's collaborating, estimated that at the beginning of the year, there were over 300,000 CBRS access points already deployed. So just to give you the idea. So that's significant, right? At $4 a piece, that's not too bad, I guess, per month, right? So that's it, and the trend continues to skyrocket. We do a lot of work with companies that are doing a lot of pilots. They have maybe 26 facilities, but they're testing one, and they're just going through the motions of different device equipment, testing some use cases, and we see it, and they're saying, yeah, so far the expectations of what the technology can do for them are matching their requirements. So, and their goal in some cases, we're with a pretty large agricultural equipment company in Iowa, that their goal is to get rid of the wires. It says in all our manufacturing plants, if this meets our requirements, no more Ethernet, it will all be wireless. So all the equipment, manufacturing, everything will be over wireless. And as far as choices on the vendor side, it keeps growing. The ecosystem continues to grow. There's already 187 commercial base station equipment. So to your point, with that, with competition, with choices, with scaling the devices too, prices come down as well. And as a reference, we help a partner do a deployment in a mining company, and the mining company had made an investment in Wi-Fi, and it just wasn't working. The environment was just too challenging for Wi-Fi. And they were putting access points all over the place. The investment kept going up and still not reliable enough. They decided to try out that. They put 3 of the radios, and they're up and running. So it's kind of starting to prove itself as well. And just to give you an idea of some of the companies, and it gets busier and busier. And this is not everybody, It's impossible to put every logo that is a member of that CBRS on Go Alliance, but just to give you an idea. So on the devices, we make devices. We're not alone. There's plenty of devices there. Just couldn't fit the Apple logo on that one. System integrators, so this will be examples of companies that can actually assist you. So if you don't have the expertise in-house, and typically an IT department, they know how to do Wi-Fi, Ethernet, and others, but they don't necessarily know how to do private cellular network, but you can hire some of them that can help you design it and roll it out even. They can install it for you. They're all certified installers as well. SaaS, on the SaaS side, we use Federated Wireless. They were one of the early entries, but now others are in. Like Google, you can go to Google and they can provide that SaaS service as well. Service providers as well. So cloud providers, this is where they're now hosting the packet core. They love that, right? Azure, Microsoft, AWS. And then the base stations, that's the ecosystem that I think every time I go to a show, I see new entries all the time from all over. And this solution is primarily US-centric because the spectrum was available here. However, in Europe, some of that spectrum is also underutilized. So there's an expectation that some other markets will start adopting and making this spectrum available in the same fashion that CBRS was made available here. So so not lacking for choices. If you wonder, where do I start? There's places you can start. My advice is if a company is interested, one place to get a lot of reference material is the CBRS Alliance. Just do a Google search. I think it's probably on Go something. You'll be able to collect a lot of information about there and then example use cases. Again, these are some of the things. In fact, we see this too. Trivia question too, if it comes up. Who's a fan of the NFL? I am. And you know how in professional football, the coach is relaying the instructions to the quarterback. It's a radio transmission, right? So before it was just some private mesh, whatever, unreliable, you can pick. But it's actually the NFL has a CBRS network in every NFL stadium, and it's only for game days for coaches to talk to players, and that's a CBRS network in every stadium. The other use case in a stadium is overflow, right? Sometimes when you have a packed arena and the network doesn't have enough capacity, some of the venues are starting to deploy CBRS so they can expand that capacity. So that's an example on sport venues. And then there's others. NASCAR, obviously, that's a good example as well. The other thing in a place like NASCAR, and I know this from going to an all-star race in Charlotte, this is quite a while ago, but one of the things they were trying to do is use GPS technology. Like when there's an accident, they draw the flag. They gotta exactly capture where the vehicle is, which is hard to do when you're going 200 miles an hour. So they were using GPS technology, but they were trying to backhaul that information over cellular, but it wasn't reliable. So this will be an example where they have full control, so they could do that. Those are probably more the cool examples, but from a business standpoint, there's more relevant cases. So I'll touch on a couple of examples. So I hit on this one. We work with a company in Arkansas. They're big in distribution logistics centers, and they're working with a company in California called Phantom Auto. And Phantom Auto builds autonomous vehicle technology. And so their whole concept is, one of the challenges, and I think it goes across other segments as well, is forklift operators. It's not necessarily easy to find good ones. So they implemented this technology in forklift operators, and they have all kinds of sensors. So this thing is super smart. It can go around on its own, and if it detects an obstruction, it knows how to avoid it or stop, or safety first. So they first started to use Wi-Fi. to test this, and it just didn't work. So they put a CBRS network in the facility, and this is one of those gigantic, Amazon-like facilities, and it works great. And then the other thing they were able to do with CBRS is, in addition to tracking the vehicle with all the sensors, they also added video capabilities. And again, this is the one where they added as a fallback the remote drive capability. So they actually have forklift operators sitting in an office. They can take over the forklift and drive it around the facility because they have full view. It's like virtual operators, but with actual machinery. And the key thing is, with this type of application, you cannot go from this side, and as you're moving across aisles, for example, all of a sudden you lost the signal, and you can't. You have to have reliable connection through the whole area. Otherwise, you can't really implement it at scale. So I think in the test facility, they were running like 70 forklifts, all going, with no operators on it, which I'm not sure I'd like to walk on that floor. The other, in this type of environments, multi-tenant commercial real estate is another area where it makes sense to build your own network. And for that is, you're not just providing broadband services to people, your tenants or what have you, but in this case, it's mostly driven around climate and access control, right? So I was at a show in June called Realcomm, and it's all about building management systems and whatever. And the technology is amazing, and the kind of things they do and the sensors they do. And then I was talking to a person who's been in the industry forever, and he said, all this sounds cool, all the technology sounds cool, but at the end, all we're doing is moving air. I said, yeah, I guess so. But it's all about that, right? But it's just got to be move air, temperature, humidity, and there's a lot of things. If you don't do that right, it's a problem. So that's another area. And last is more, manufacturing. Right now, there's a lot of automation with robots and stuff. So for them, it's not necessarily so much about the speed, it's the latency, right? So because these are high speed, and you can't afford to have unpredictable latency where instructions get sent, and sometimes it took 20 milliseconds longer than the other. So it becomes an area. That also high use cases as well. But anyway, again, these are, in these cases, they were looking to replace the wires, right? Because if you need to move that line, if it's all wired in, it's not as easy as if you just take the whole thing, move it, and you don't have to touch anything. It's connected regardless of where you are inside the plant. Oh, the other thing too, and that's a good point here, is that with cellular in general, you can set up quality of service, you can set up priorities as well. So you can determine within a plant, you can give, hey, top priority, right? So give whatever these guys need to use the network, they have priority of other use cases, like somebody with a tablet, taking inventory, for example. So you have control of that. And then the security side too. It's all contained, so it's a lot more secure than other options. So as far as I know, nobody has been able to hack the air interface on a cellular network. Usually the hacks occur from within, or once it goes beyond that into more the IP world. All right, and just to recap, CBRS, it's band 48, it's that 3.55 to 3.7 gigahertz. By the way, there's other private spectrum available in the US, but those there's companies that own that spectrum, and they're making it available for this type of things. But CBRS is the one that is, more broadly available, and you don't need to have a license to operate it. You can just use a GAA channel and go with it. You have 3 tiers. At the top, you don't want to mess with the US Navy. I certainly don't want to. So they're the ones that have ultimate protection, but chances are you're not going to run into them very frequently. Hardly ever, probably. And if you do, good luck. Then the PAL licensees, and again, you'll run into them, but as you can see with the SaaS service provider, you have an ability to dynamically coordinate that. So it's not a free-for-all per se. There's at least an entity looking at what's going on that is also aware of everything that gets installed. In unlicensed spectrum, this free-for-all, right? You can put your thing here, and I can put it right next to you, and there's no recourse to say, hey, make him go away. Here you do have some recourses for that. That's it. I guess I'll leave it there. So just questions. I think we have about 5 minutes left. So let me go to you and then you. Go ahead.
So the spectrum is open for anyone to use
Yes.
as long as you use a SaaS service, right?
You have to use the SaaS servers and you have to register whatever you put up and light up. You have to register that with the FCC, which you do through the SaaS service provider.
Any restrictions on the use once you put up a box?
No, no.
So you could resell it to a community for
Yes.
wireless access.
Absolutely, absolutely. In fact, I think one of the big drivers is the digital divide, right? And in fact, the federal government has put out a lot of funding to help provide broadband services to underserved communities. So this is one way where you can do that. And chances are you're not going to have too many issues if you're like, in the center of the U.S. in a rural area. Chances are this will be a way to do that. I mentioned the example that this is happening, that Southern Link, which is owned by Southern Company, is actually in the middle of an effort with the state of Alabama to do just that with their network using CBRS spectrum. Yes?
So, okay, so MultiTech is not the only company that produces
No.
equipment for this CBRS system.
Mm-hmm.
Are the various pieces of equipment from different vendors interoperable? I mean, is
They
it
are.
industry-wide standard?
Yes, that is. In fact, that's why the ONGO Alliance makes sure that that is the case. But as long as you're building equipment following the 3GPP standard, which is the same standard that Verizon and all the cellular carriers in the world have to follow, equipment is interoperable. So you can have a mix and match on the radio stations, on the user equipment. So in my case, you can use one of our gateways to connect a controller, for example, and then you can also have iPhones running on the same network. So it's all interoperable. Yes. Let me go to him and then you. Uh-huh.
Yeah, I'm just curious what your thoughts on that. Like LEO constellations starting to come online, and like how's
Mhm.
that going to impact the space for like more rural applications and like direct device.
Yes. So with satellite, and that's something that at the 3GPP is the consortium that defines the evolution of cellular technologies. And I don't look ahead. I'm trying to live in the now, but I do know that the next in future releases they will bring the capability to bring satellite into ground-based networks. So what that means, when you think about it, if you see this slide here, right? This is the radio access. So this could be anything. This could be a satellite hook. Right? So as long as you can bring that in and you define how that data gets converted and transformed and how you track the users and everything, you can actually tie in a satellite service to a ground-based service. So I think that is coming. It's probably a couple of years out, but I think some of the effort to integrate satellite and ground-based systems into a cellular network is coming. Mm-hmm. Challenge with satellite tends to be availability of equipment. There's not too many choices, and then cost, right? It tends to be costly, but having said that, I don't know if anybody has played with Starlink. I have a colleague who did. He wanted to take a month off in Yellowstone, so he bought one of them, and he said it was easy to set up. Still a little pricey, more expensive than your home, but I didn't think it was crazy, and it worked pretty well. He was getting, pretty reasonable bandwidth.
It's getting better and better.
Mm-hmm.
You're constantly watching
Yes.
their satellite links enabled.
Mm-hmm.
They're still working on, but it's interesting to see.
Yes. Frank.
What's the coverage of one?
Same as you get a coverage here. Typically a cell site, 50 watts. You can get a mile or two probably around the tower. You don't want to go too far because you remember one of the characteristics of cellular is you kind of want to control that a little bit because you want to be able to reuse frequencies. So if you go too far, you got to wait. You got to go 50 miles to reuse the same frequency. But in a metro area, your cell sites I think cover 1 or 2 miles around the site, and they do it by controlling. The antennas are very sophisticated. Yeah. Anybody else? Yes.
So in cellular, you basically control access through a SIM card, right?
Yeah. It's a combination. And the SIM card, that's where you store your credentials. But in the Evolve Packet Core, you have the mobility entity handles the authentication. So one is the SIM has to match up what it's on the core side, right? It's pretty secure.
Okay, so
Pretty
you
secure.
do still have that same type of mechanism
It is. You need a SIM. Absolutely, you need a SIM. It's a cellular network, so same things you need to run your phone, you need to run with your own CBRS. There are SIM providers that can make SIM cards available, and they have to be configured to support your network. There are SIM cards that support the ability. I think somebody asked me earlier about the ability to. I want it to work on my network, but if I'm outside the range, I want to use Verizon or T-Mobile or whatever. So, in fact, carriers are offering this for their large enterprise customers, where if a customer says, I'm interested in deploying my own CBRS network, they say, we'll do it for you. So they're doing it on behalf of, but they're setting it all up. And it makes sense to me because I don't care how much money you invest, you're never going to have more experience than a cellular operator on how to do a cellular network, right? So it's a good choice, but it gives customers the ability to leverage that and bring overhead down, or in some cases, maybe driven by security concerns where there's certain application I want to run on my own network and I don't want to be using a public network for that. Any other questions? All right.
Thank you.
Thank you very much, everybody.